Session 5.5 Finding values of variables for normal distributions. Finding the value of an observation from each z-score. Remember this formula. If we have the value of the x and we want to convert it to the z-score, we will plug into this formula. We learned this formula by the previous sessions. And right now, if they given the z-score and I want to find out the value of the x, we could take advantage of this formula. So what we're going to do, we multiply the sample standard deviation for both sides. And then these two, you could cancel out. You're going to get sample standard deviation times the z-score equal to the value of x minus the sample mean. And then we're going to add the sample mean for both sides. So you're going to get the new formula, x equal to the sample mean plus the z-score times the sample standard deviation. This is how you guys find out the x when they're given the z-score. Example, find an observation from each z-score. So this example, when they're given the z-score and I want to find out the value of x in here. Remember the IQ test example? IQ tests are normally distributed with the mean 100 points and the standard deviation 15 points. Right now, we know about the z-score, z equal to 4. What is his IQ score? So we are looking for the x in here. So we'll be using this formula. You know the sample mean is going to be 100 points, sample standard deviation is 15, and z-score is going to be equal to 4. So plug it in. Use the calculator. Make sure you do the multiplication before you add up the hundreds in here. You should get 160. So his IQ score is 160 points in here. Another example. A professor gives a test to her calculus students. The scores are approximately normally distributed with the 75 points and standard deviation 9 points. The professor decides to give A's to approximately 10% of the students, but not less than 10%. Find the cutoff score for an A. So this example will be using the table A2, the z-score table. So let's sketch the picture. And we know this is a normally distributed, right? So that's why we have the normal distribution. And we have the mean 75 points in the middle. And they say the professor decides to give A's to approximately 10% of the students. So means on the top of the 10% of the students, they're going to get the A. So on the top 10% is talking about somewhere like here. So 10%, this is talking about the area of the white tail. Okay, 10% equal to 0.10 in here. Okay, the area of the white tail is going to be 0.10. So think about it. What is the area to the left if this is going to be 0.10? Remember what is the total area under the curve? This is going to be equal to 1, right? Total area under the normal distribution curve is going to be 1. And we could do 1 minus 0.10. So which is going to be 0.90. So now we know about the area. That's a 0.90. Okay, we want to find out the z-score at this point. So let's look at the table A2. Okay, remember on the left-hand side here, this is represent the z-score. And this is like 2 decimal space of the z-score here also. And then in the middle, the 4-digit number, this is represent your area. So right now, I know the area is going to be 0.90. I need to look for the area from this 4-digit number. Which number is going to be really close to the 0.90? Okay, you can see here 0.5, 0.6, 0.7, 0.8. Okay, this is going to be close to 0.90. So we have a 0.8980 0.8997 or 0.9015 in here. Okay, so these two should be really close to the area of 0.90. But which one we're gonna pick? We want to pick the one that's the closest to the 0.90 here. So I will use the 0.90 minus 0.8997. Okay, I want to find the difference. This is going to be 0.0003. And I also use this one minus 0.90. Okay, you can see that's a 0.0015. So which one is going to be the smallest one? Okay, we're going to compare these two numbers digit by digit from the left to the right. So this is a 0, this is 1, so this one will be smaller. This area 0.8997 is really close to 0.90, and then we're going to look for the z-score. So that'll be 1.28. Okay, 1.28. Okay, one more time. They're given the area and I want to find out the z-score. So the area is 0.90. So I'm gonna look at the 4-digit number. Find the one who close to 0.90. And this one will be close to the 0.90. And the z-score will be 1.28. Okay, now I want to find out what is my x. Okay, what is the cutoff score for an A in here? I know the z-score. How can I find the value of the x? We'll be using this formula, just like the previous example. We know the mean, we know the standard deviation. We just found the z-score is going to be 1.28. So plug it in. You're going to get 86.52. So the x is 86.52. And if we do the rounding, we could do like x equal to 87. But think about it. If this is 87 points, less than 10% of the student would get the A's. Okay, if you plug it in, you only find it out it's only 9% from here. So that's why we need to get at least 10% of students getting A. We're gonna round it down to 86 points. So the cutoff should be the 86 points. So the students who took the test, if he got like 86 or above, he gonna get the A in this class. So this example, they given the area, and then we use the table to find out the z-score. After we know the z-score, we'll be using the formula to find out the value of x. Okay, so this is gonna be the method 1 using the table A2. So the next one will be using the calculator. Okay, using the TI-83 plus 84 plus calculator. Given the area to the left or right, and then find the value of x. Same idea, we're gonna go to the second vase inverse norm. Okay, given area, find out the x. We'll be using the inverse norm, area from the left, and then the mean, and then the standard deviation. We don't need to use the formula if we're using the calculator here. So let's try the same example, but this time we'll be using the calculator. So again, we have the picture, sample means in the middle. We have the top 10% in here. First, figure out the area from the left. Again, 1 minus 0.10, which is going to be 0.90. Now we know the area from the left. We'll be using inverse norm, area from the left, the mean, and then the standard deviation. You could get x equal to 86.533. So we just explained it, right? If we round it up, we only get like 9% of students getting A. So we're gonna round it down, that will be 86 points in here. For the exam, for the chapter exam and the final, if you're using the table, show me all those words, show me the picture, show me the area, the z-score, and also the formula, how you get this one. If you're using the calculator, show me this picture again. I need to see this. Inverse norm, what did you put? what area, what is the mean, and what is the standard deviation, and what is your final answer. Okay, if you're using the calculator, show me this word and also the picture. Okay, another example, comparing C-score of two data from different distribution. Maria and Roberto took the test on probability in two different sessions of p-statistics. Maria scored 91 points on a test with the mean 77 points and a standard deviation 6 points. Roberto scored 80 points on a test with the mean 68 points and a standard deviation 4 points. The test score on each test are approximately normally distributed. So we know this is the normal distribution. And then since they took like the different tests, the test will have a different mean and different standard deviation. So first, find the C-score for the Maria test score. What does it mean in this situation? So this time, Maria got 91 points. This is the value of X. And I want you guys to find out the C-score. So we'll be using this formula. So you know the X, you know the mean, you know the standard deviation. Plug it in. You should got 2.33. Okay, this is gonna be the C-score. And what does it mean in this situation? So remember what's the definition for the C-score? The C-score means how many standard deviation above or below the mean, right? Right now we have a positive. So we know we have a 2.33 standard deviation above the mean. So C-score is 2.50, which means that Maria test score is 2.33 standard deviation greater than the mean of her session score. Okay, now I want you guys try the example to find out the C-score and what does it mean in this situation. Okay, Roberto got 80 points, right? So 80 minus the mean divided by the standard deviation. You could get the 3 in here. So the C-score is 3 means that the test is 3 standard deviation greater than the mean of his session of the score. Okay, number 3. Assuming a typical student in one class knows the materials as well as a typical student in the other class. Determine whether Maria did a relatively better than Roberto. So we know Maria got the test score is 91, right? Maria test score is 91. But Roberto, he only got like 80. So if you only compare with the number, you're gonna say, hey, Maria get the test better than the Roberto, right? But you know this is a two different tests. They have a different mean and different standard deviation. So we can't just compare with the test score. So we could look at the curve though. And this is the Roberto test. His test, the sample mean is going to be 68 points. And then standard deviation is about 4 in here. Okay. But for the Maria test, her test, the sample mean is 77. So you can see the curve is going to be moved to the right in here. And then standard deviation is about like 6. So it's going to be much wider compared with the Roberto's test in here. So when we look at this picture, we know that Roberto's test was harder than the Maria's because the sample mean is much lower than this one. Okay, and then now we're gonna look at the C-score that we found from the part 1 and part 2. Maria's C-score is 2.33. And then Roberto's C-score is gonna be equal to 3. If we want to know whether Maria did a relative better than the Roberto or another way around, we could just compare with the C-score. Since Wobato's C-score is 3 and the Maria C-score is 2.33, we know that Wobato did a relatively better than the Maria. So sometimes we can't just compare for the test score. You have to look at the sample mean and the sample standard deviation. Unusual observation. Assume that some data are normally or approximately normally distributed. An observation is unusual if it is more than 1.96 standard deviation away from the mean. So we consider this as a normal distribution. Sample mean is going to be in the middle. You could see when we say mean plus 1.96 times the sample standard deviation, or the mean minus 1.96 times the sample standard deviation. We consider that if your x is lying in between this part, this is considered usual. If your value of x is less than here or greater than here, we consider this as unusual value. Okay, so you could look at the c-score also. If your c-score is in between negative 1.96 to 1.96, we consider this as a usual value. But if your c-score less than negative 1.96 or greater than 1.96, we consider this as unusual value, just like the previous example. Maria's c-score is equal to 2.33. So 2.33 is somewhere like here. Her test score is unusually high. And for the Wobato c-score is about 3, so just like here. So his test is also unusually high. And then why we pick like 1.96 in here? Because when we have a 1.96 sample standard deviation here, you're gonna find it out the area of the white tail is gonna be 0.025. Same idea of the left tail. This is gonna also be 0.025. When you added up these two numbers, that will be 0.05. Okay, we call this as a 5% rule. And for this book, we'll be using the negative 1.96 to 1.96 in here. And actually, we always round it up. We're going to say if the z-score is in between negative 2 to 2, that's unusual. If the c-score strictly less than negative 2, that's unusual. Or c-score strictly greater than 2, that's unusual also. Determine whether an observation is unusual. An observation of an approximate normal distribution is unusual if either of the following equivalent statement is true. First, if we find out the z-score is less than negative 1.96 or greater than positive 1.96, we know that the value is going to be unusual. Or the probability of randomly select the observation or one on the same side of the mean, but even more extreme is less than 0.025. So if you're finding the probability and the probability is going to be less than or equal to 0.025, we call this is going to be unusual value. Okay, example. A company claims that its low salt potato chips contain only 85 mg of sodium per serving on average. An independent company randomly selects and tests a batch of the low-salt potato chips, which turns out to contain 104 mg of sodium per serving. Assuming the sodium level per serving of the low-salt chips are approximately normally distributed, with the mean 85 mg and standard deviation 5 mg. Find the probability that a randomly selected batch would have at least 104 mg of sodium per serving. And this example will be using the table A2. So remember, find the probability. Remember on the section 5.3, we say that if we are looking for the probability, means we are looking for the area. So we want to find the area when the x is at least 104 mg. So first, let's draw the picture. This is a normally distributed with the mean in the middle, 85. And then when the x is going to be 104, so somewhere like here. And we want to find the probability that at least 104 milligram. So we are looking for the area on the y tail. Okay, now we want to use the table A2 and we have the x. So first step, you want to find the c-score. You have the x, find out the c-score, so plug it in. You should get 3.8 in here. Okay, so this is gonna be the c-score. We have the x, we find out the c-score. So now you have the c-score 3.8, and I want you guys find out the area to the left, use the table A2. You should get 0.9999. Okay, I'm gonna show you guys how to use the table A2 again. Let me finish this one first. When you have the c-score 3.8, you're gonna find out the area to the left is gonna be 0.9999. Okay, this is talking about area from the left. But right now we are looking for the area to the right. How can you find the area to the right? Total area under the curve is 1, right? So area to the right will be 1 minus 0.9999 in here, which is going to be 0.0001. And 0.0001, the probability very close to the 0. Okay, so actually for my pictures in here, the 104, it should be really to the right somewhere like here. Since the area really small, so it would not be visible. We may not see it like this. Okay, now let me show you guys how to use the table A2. Okay, we know the c-score is going to be 3.8. So let's look at the table. Positive c-score here, you can see 0, 1, 2, 3. Okay, the greatest c-score is going to be 3.5 and up, okay? So we only can have one area here. 3.5 and up, that will be 0.9999. So that's why we got like area to the left is 0.9999 in here. Okay, subtract from 1, we're going to find out the area to the right. So this is how you guys use the table A2. When they given the x, first find out the c-score. After you know the c-score, you're going to find out the area. Okay, same example, but this time we'll be using the calculator. Okay, we have the same picture, mean in the middle, 104 somewhere like here. Okay, and this is what we're looking for because we want to find the probability, means we are looking for the area. So when we use the calculator to find the area, we'll be using either normal CDF or inverse norm. Okay, so we have a normal CDF starting from here, 104 to 1E99, and then the mean, and then the standard deviation. Okay, now we use the calculator. Normal CDF, so second bars, choose the number 2, normal CDF. 104, comma, 1. The E using the comma, so second, comma, 99, comma, 85, comma, and then standard deviation 5. Close it, enter. So you're gonna get 7.237 E negative 5. Make sure you look at the end from here, E negative 5. This is my answer, 7.237 E negative 5. Remember, this is called scientific notation. This is means 7.24 times 10 to the power of negative 5. And since we have the negative, we're gonna move the decimal points to the left. So this is gonna be your answer, 0.000724 here. Okay, and from the previous example, when we're using the table A2, we only get like 0.0001. Okay, if we try to 1 to 4 decimal space, this is 5 or above, so we're gonna add 1 from here. If we do the rounding, we're gonna get the same answer, just like the previous example. That's it for session 5.5.